can be the same across many different data sets, and the effort from the provider side is still quite low.
Okay, thanks, Jonathan. We'll go on. We'll skip over that point. So we're now going to go on to looking at DOR 3, and the difference in DOR 3 is that, because one of the criticisms is that we want, and there's a strong push to get people to harmonized data, where the data is interoperable because it's all using the same standard. There are many reasons that's a very desirable place to get to. There may be many reasons why it's hard to get to. From where you are starting from. And the point about Data Connect is you can start from where you are. It will help you with that migration if you want to put in the additional effort. I will skip back to that previous slide, because the point it was referencing that there is more effort on the work of the provider to do what we've just seen. The point is, Data Connect doesn't set out to burden a provider with that additional cost. It's really looking to say, if you've done that, if you've done what Cinica did, or if you've done what dbGaP did, then you should enter through that door and take advantage of what's possible. So now we're going to look at the third level, where we are getting to data that is more harmonized, that is using data that conforms to some standard, and particularly where that standard is defined in some kind of semantic repository. So the Data Connect data we're going to look at for this example comes from the Cancer Data Service. And so again, with the same scenario that we just looked at, if my computer will keep up with me. What do we start with for the Cancer Data Service? Now, Cancer Data Service is using a dbGaP. And so everything that we've seen about the use of dbGaP in Data Connect applies. But we're actually going to look at a dictionary again, just as Cinica had provided an Excel data dictionary. Cancer Data Service has described its data dictionary in Excel. But here's one of the things that's different here. Over on the right here, let me increase the size of that. We can see that we have references to NCI Thesaurus and a CDE ID, and these CDE IDs are referring to what's called the Cancer Data Standards Repository. So the entry point here is, as before, we have a data dictionary that's been expressed in semi-machine readable form, and we have, but the additional thing that we have is references. And so to existing CDE. So in a way, this makes the task easier. Just open the tabs that I preset up for this demo rather than messing around with others. So this is the DOR 3 example. So if we do the same thing that we did with the previous data sets, which was to take the Excel spreadsheet and turn it into a JSON schema. We've already done that. Before, we were including in the schema the actual lists of values, but in this case, there's no longer any need to do that. This can refer to the CADSR. That's all we need to say about gender. Because gender in this study used this standard. We actually put in here the description of it as well. That could come from the standard too, to be honest, but it's useful to have it here. And just to show what that links to, what CADSR is doing is providing a machine-readable version, and this is horrible, detailed XML, but just to demonstrate that there is machine-readable in extreme detail, which I'm not going to go into all the details of. That's far better covered by people who know CADSR. The point is it's machine readable and tractable. So in our notebook, and I didn't do that full table that we saw in the data dictionary. We've just picked 3 elements from it here. We've got the age, we've got gender, ethnicity, and race. And you can see that for all of those last 3, it refers to the Cancer Data Standards repository. And what we can do is programmatically, and the person we're being at this point is the data analyst who's using Python notebooks to analyze their data. That machine-readable data, this would be, if you're not a Python expert, this is hieroglyphics. But this is what Python program data analysts do using data frames, using dictionaries in Python to extract from that the value. And this is extracted from the Data Connect. This is what the Data Connect schema. Now we're going to use, through that ID, which we're resolving by identifiers.org. So these are globally unique identifiers. We can then use that, and again, this is code that a data analyst would write. This information then has been pulled from that XML that we were looking at, and it's telling us there are 2 versions of that common data element. You could decide which one you wanted to work with, and there are links here to what the value domains are. The value domain is the list of values that data element may take. And so that's one route for it. The other, and I'm not going to do this live because I have to this is a development instance where that metadata repository, the MDR, and remember the word metadata here means something more specific than what it's come to mean in genomics, which is kind of everything but the sequence. This is talking about the metadata that defines the variables. It's also available through a SPARQL endpoint. And the point here is not to show how to use those resources. The people who would want to make use of this are very familiar with those resources in general. We're just illustrating that this is possible and that we could use, we did it here through the XML version, we could also do it through SPARQL, where we pass a query, and here we're getting back from CADSR the list of ethnicities that were defined. So that's pulled from a semantic server. So that is the demonstration of level 3, where you get to the point where one is using semantic resources. And I think at this point, Jonathan, I think we resume our slideshow. And I think we have a wrap-up slide on this. Do you want to take this?
Sure, yeah. Yeah, I think Ian kind of did wrap it up for level 3 is, again, it can be a relatively low effort for a data provider if you're starting from a point where the data set already is defined in terms of some external model like CADSR. And that provides additional benefits to people who are consuming the data or trying to discover the data. And I think also importantly, it enables tools that wouldn't be possible at levels 1 and 2 when there's multiple data sets from different providers that refer to the same shared concepts. And I think that, I think that takes us to our next slide with questions, which is we've kind of reached the frontier of where Data Connect 1.0 got to in terms of the specification. And so now there's the questions, what mappings are people using, who's already got some level 3 data that would be a good candidate for representation